And this is not in your book, but it is an important application of integrals, and I want to introduce it now because we're doing definite integrals, and it fits in very closely with what we're doing. And it's a fairly simple idea. The idea is we can use an integral to figure out how much something changes, how much a quantity changes. So this is kind of a formula, the type of formula you would see in the book. This is something I would recommend writing down because it's not in the book if you want to try to remember it. Oh, and it's wrong. But I'll fix it real quick before you even notice that it's wrong. So if f prime is the rate of change of f of x, then the integral from a to b of the derivative of the rate of change is going to give you the total change in f from a to b. Now write that down and I'll explain what it means later. If we know how fast something is changing, and I'm going to use driving a car example because I like going back to that example because it makes sense to people. Let's say we have a function that tells you how fast you're driving at any given time. What we can do is we can take the integral of that function over whatever period of time we want, and that's going to tell us how far you've driven during that period of time. It's not going to tell you where you are, because you don't know necessarily where you started based on that rate of change, but it is going to tell you how far you've gone. So if I tell you, let's say you're on a 5-hour drive, there was a test question on the last test that involved a 5-hour drive. You know how fast you're going through that whole trip. If you take the integral, say from the end of the first hour to the end of the second hour, that'll tell you how far you drove during that hour. Does that make sense? So your speed is how fast your position is changing. So that the speed would be the f prime of x. That's your rate of change of your position. So if you take the integral from 1 to 2 of your speed, that's going to tell you how far you went. That's your change in position. Then if you couple that with where you started, let's say you know where you started and how far you went, then you can figure out where you are. Does that make sense? So net change, when we take the integral here and we're saying the integral is net change, the net change is just how much the function changes. Okay, so here's the AP test example that we did a couple weeks ago. We skipped part B though because we didn't know how to do it yet. So let's go back to the problem and just talk about what's going on in this problem again. During a workday, the rate that unprocessed gravel is arriving at this processing plant is modeled by this function big G. So that's how fast the gravel is coming in. Okay? What we want to do for part B is find the total amount of unprocessed gravel that arrives during the 8 hours of operation on this workday. So what we can do, we don't know how much gravel we started with. We don't necessarily want to know how much we end with. We just want to know how much arrives. Well, we know how fast it's arriving. So how would I find how much arrives throughout the whole day? What would I do? We would take an integral. So for part B, we would say the integral from, well, what are our limits going to be of integration here? Yeah, so we're starting at the beginning of the workday and going for 8 hours of, well, so we're going to integrate the rate of change. Well, it already says here that the rate that it's coming in is this big G. So this is the derivative of the amount of gravel that's there. That's already the rate of change. So we're going to integrate that function right there, the 90 plus 45 cosine of t squared over 18. Now, there's two things that I'm missing with this integral. What's one of them? Haley?
Like the normal dx.
Yeah, and we're not going to differentiate with respect to x here, but we're going to, or it's not a differential with respect to x, it's a differential with respect to t. Okay? So I was missing the dt. What else am I missing? This one's not as obvious, and we haven't talked about this a whole lot as far as integrals go, but we've got a notation problem here. What this says is actually completely nonsensical because we're going to integrate from 0 to 8 of 90, and then we're going to add on 45 times the cosine of this times the differential of t. And these are two separate terms. And what we want to do is we want to integrate the whole thing. So I need to put that whole thing in parentheses. And those parentheses are really important. Not only important when you're putting stuff into your calculator, but also important because it means something different. In fact, it doesn't really mean anything without the parentheses. And then all you'd have to do for this problem is evaluate that. Figure out what that integral is going to be. And just for practice here, I want you to go ahead and do that in your calculator. So type into your calculator. You can either do it on the home screen or you can do it on the graph. I think with a function like this where I don't know exactly what the function is going to look like, I would probably just do it on the home screen. But that's up to you. When you type this into your calculator, you get 825.551 rounded to the nearest thousandth. First of all, be sure you round to 3 decimal places. That's 3 places after the decimal, not just 3 total, but 3 after the decimal. And then the other thing you want to do is make sure that you include units. To answer the question that was asked before, sometimes you have to have the units, sometimes you don't. Sometimes you won't get the point if you don't have the units. There's not really a good way to know whether or not you have to have them there. Sometimes it will say including units. I don't think this one does, but I would still include it just to be sure. So this is 825.551 what? Tons. So during the course of the workday, 825.551 tons of gravel arrived at the plant. Let me ask this, and you should be able to answer this question fairly easily, I think. It does say that they can process gravel at a rate of 100 tons per hour. So are they processing more or less than they're getting? Less. So they're actually acquiring more unprocessed gravel during this day than they are able to process. That isn't good. They're going to have to work on their business model, I think, a little bit. So just to let you know how the AP test was graded, this is off of last year's AP test. This problem is worth 2 points. A lot of students, and what the AP does is they release notes about the test afterwards, and they say like what common mistakes were and stuff. What a lot of students did is they got 1 point because they had the answer right, but all they did was write down the answer. So they wrote that 825.551 tons, and they got the point for that, but they didn't show how they got it. And this is an important thing to know about the AP test. They don't just want the answers on the free response, but you need to show how you got it. You need to show what calculus you're using to get it. So in this case, you need to show that you understand that the amount of gravel coming in is the integral of the rate of change of gravel coming in. And it's the integral from 0 to 8 of that.